Welcome, chemistry students. So in this lesson, we begin our last unit of the course, gas and atmospheric chemistry. So to start, we should look at then pressure and talk about what pressure is and how we can measure it and their different units. Okay, so let's start. So pressure, here's your definition, your basic definition of pressure. It's simply the force exerted on an object per unit of surface area. Now, if you're anything like me, that goes in one ear, out the other. What I like to think about when I think about pressure is this formula. Now, you might not be like me. You might love this definition here, and that might work just fine for you. So either way, let's go over both of them. What I like about the formula, however, is it tells me that pressure is simply a force, right, exerted per a unit area, like the definition says, admittedly. So if, for example, someone is stepping on a hardwood floor, let's say on a very small area here, all of that force exerted by a person's weight or mass because of gravity is then exerted on a smaller area here and can leave little nicks on the floor, and you don't want that. So if this person removes their shoes, right, removes these types of shoes, these high heels, and walks instead on bare feet or socks, it's probably a lot better for a delicate floor. So this shows you that a greater area that can allow for this force to be distributed means less pressure. Okay, now that is a different scenario when we're now looking at gas or pressure because of gas or atmospheric pressure, but that idea is still the same. When we look at a gas here, we can see that different amounts of pressure based on the different number of moles of gases in the same volume can add to increasing pressures such as we see in this picture. So a certain number of moles of hydrogen gas gives us 2.9 atmospheres confined to this area here with a certain amount of pressure exerted downward. More moles and more pressure exerted downwards, meaning also more pressure. So we're just continuously adding more and more pressure as we increase number of moles and increase pressure downward. Okay, so let's get into how we can measure pressure. And famously, this Italian physicist and mathematician, I believe his name was Evangelista Torricelli, living in the late Renaissance period, early and mid 1600s, he developed a barometer, known for developing the first barometer. So what he did is he took meticulous measurements using a simple barometer, something like this, where you had a vessel filled with liquid mercury, a glass tube with air vacuumed out of it, right? Place that then into this vessel of liquid mercury and then took measurements. Set millimeter markings along this, right, along this glass tube now filled with mercury because it's vacuum. You vacuum air out of it, creating negative pressure. Place it inside a vessel of mercury. Mercury gets suctioned up, and then you take measurements. Right, and over a period of time, Torricelli developed or had a lot of data then for all these measurements. Depending on each day, the measurements would vary slightly. Right, so on average, you figure that your typical day over a long period of time measuring was about 760 millimeters of mercury is what this would rise to. So he noticed that on a rainy day, perhaps there was a lower pressure. On a day where you measure a higher pressure, it was more of a clear day. Now that makes sense because we see that when the pressure, if you tune into the weather network or look at your apps on your phones and you see if pressure is lower, it's probably there's probably gonna be a chance of some kind of precipitation. If it's higher, it's more likely to be a clearer day. So atmospheric pressure then started to be standardized later on, and we saw that 1 millimeter of mercury is defined as 1 torr after Torricelli, right, at 0 degrees Celsius. So this is the conversion then. As we continue to add on to these different units, 1 atmosphere, one of Earth's atmospheres, is equal to 760 torr, which we know to be equal to each torr is 1 millimeter of mercury, which gives rise then to these different conversions. So 760 millimeters of mercury is equal to 760 torr, which is the same thing as 1 atmosphere. Now, you don't usually see these on your weather apps anymore. Well, at all. Now you usually use kilopascals after a French scientist, and 101.3 kilopascals is your pressure at sea level, okay, at 0 degrees Celsius. Okay, so this is the conversion for all of these different measurements or different units of pressure. And using a bit of math here, and what we've hopefully perfected now, the factor label method. Right, you can convert between these different units, right, and different amounts using the factor label method. So here, the pressure of 100 kilopascals can be converted to torr in this way. So again, you write down what you need. Okay, I have the answer covered by the star, but essentially you need torr, right? So we need torr. What do we have? We have kilopascal, right, given to you in the question, kilopascal, and this is a period right here, kilopascal. Then we're going to multiply that by a conversion. All right, so what's a conversion? You write the unit you want to get rid of at the bottom, the unit you want to keep at the top, and then you go back to your conversion factors and see what numbers are associated with each. So 760 is torr. So you write 760 torr. And 101.3 is kilopascals, right? 101.3 is kilopascals. So notice kilopascal cancels out. You do the math, 100 times 760 divided by 101.3, and here is your answer. 750.2 torr. Since there are 3 sig figs because of that period there, that means you just leave it at 750. So I've underlined that sig fig. There should be a 0 here, but there you go. Okay. So that's essentially it for the introduction to this unit and just talking about pressure. So here's your home fun. These are the questions you should look at. Pretty short and sweet lesson, right? Post any questions if you have any. I'll be happy to answer them. Hope this helps.